Today we're going to look at the second method of solving systems of equations, which is substitution. So here, when we're solving by substitution, we can still get three different types of answers, just like we did with our graphing method. The first one would be one solution, right? And that solution would have an x and a y value. And in substitution, what that's going to look like is that you will have an answer for x, so any value for x, and an answer for y. So once you find one of those variables, you're going to plug it back in to find the other. The second option is to have no solution. So remember, no solution when we're graphing was when we had parallel lines. When we're using substitution, no solution would be if when we substitute and we're trying to solve for our variables, if the variables cancel, so if the variables cancel out, and you're left with a false statement. So you're left with a statement like 6 equals 10, or negative 3 equals 5. You don't have any variables left, but you're left with a false statement. That would be an example of no solution. And then our third one is infinite solutions. So with our infinite solutions, remember on a graph, that'd be when we have multiples of the same line, right? Graphs on top of each other. But in substitution, when we go to substitute in the expression and look to solve for the variable, here our variables will cancel out. So once again, you're just going to be left with numbers, but this time you'll be left with a true statement. So after your variables cancel out, you'd be left with a statement like 12 equals 12, or negative 3 equals negative 3. And with that being true statements, you would realize that those are going to be the same lines, and you would have infinite number of solutions. So let's look at the steps to solving a system of equations by substitution. The first step is to get one of your variables by itself. So ideally, you're trying to get the variable that does not have a coefficient, right? That does not have a number in front of it. So you want to get either variable, x or y, by itself. Like I said, you want to look and try to get the one that does not have a coefficient in front of it. That way you don't have to deal with any kind of fractions. After getting that variable by itself, you're going to take the expression that variable is equal to, and substitute it in the opposite equation. So once you get the variable by itself, you're going to take what's on the other side of the equal sign and plug it in for that variable in the opposite equation. The third step would be then to solve for the remaining variable. So at this point, you're just going to have one of your variables, either x or y, in your equation. You're going to solve for that variable. And then your last step is to substitute your answer back in to solve for the opposite variable. These steps will make a little bit more sense as we start looking at some of these examples here. So as I move down here to looking at this first example, we have negative 2x plus y equals negative 9, and 4x plus 2y equals 22. So looking here, we have four different variables, right? We have two x variables and two y variables. The one that's going to be easiest to get by itself will be the one that does not have a coefficient in front of it. So the one that does not have a number in front of it. So here we can see that our y variable in this first equation does not have a coefficient, so that is the one that we're going to try to get by itself. So looking at this equation, negative 2x plus y equals negative 9. In order to get that y by itself, we would need to cancel out this negative 2x by adding it to both sides. When we add it to both sides, it's going to cancel out over here on the left, and we're going to be left with y is equal to 2x minus 9. So that was the first step, getting one of your variables by itself. So in this case, we got this y by itself in the first equation. So the next step is to perform your substitution. So here you're going to take that expression that y is equal to, and you're going to go substitute it into the opposite equation. All right, so we're just going to plug in the 2x minus 9 in place of y. So rewriting out the second equation, we get 4x plus 2, and here instead of y, we're going to plug in the expression 2x minus 9, and the rest of the equation is equals 22. So we've just plugged in the 2x minus 9 in place of y, the second equation, and now we have an equation that, as we noticed, just has x variables, right? So now this is an equation that allows us to solve for x. So to do that, we're going to distribute this 2. So we still have the 4x out front. 2 times 2x is 4x. 2 times negative 9 ends up being a negative 18. Now combining your like terms on the left side, these 4x plus 4x give us 8x. We got 8x minus 18 equals 22. Adding the 18 to both sides, we get 8x is equal to 22 plus 18 is 40. And then to divide by your coefficient, here we find the value of x to equal 5. So now that you've found your answer for x, you're going to take that 5 and then substitute it back in for your x variable. So I'm going to just substitute back into this equation where we already have y by itself. So plugging it back into that equation, I get y is equal to 2. And then here, instead of the x, we're going to plug in the answer we got for x, which was 5 minus 9. And this allows us to then solve for our y variable. So here we find that y is going to equal 1, x is going to equal 5. So here our solution is going to be that point 5, 1. So that is going to be the point where those two lines cross, and we can check it by plugging that back in. So if you wanted to use your calculator to check your solution, you would plug that back into each of these equations, right? So plugging 5 in for x and 1 in for y. You want to check just to make sure that those things come out to equal each other. So negative 2 times 5 is negative 10. Negative 10 plus 1 does equal negative 9. And your answer should work in both equations. So if I go plug it into the second equation, 4 times 5 plus 2 times 1 should equal 22. And 4 times 5 is 20. 2 times 1 is 2, so 20 plus 2 does equal 22. So you always want to check your solutions, especially when it comes to quiz and test time, to make sure that you got that right. As we move over and take a look at the second page, looking at our second example here, once again, you want to try to identify which of these 4 variables is going to be easiest to get by itself, right? So you have the x and y in the first equation, the x and y in the second equation. You want to look for which variable does not have a number in front of it. So here we see that the x in our first equation does not have a number in front of it, does not have a coefficient. So that is the one that I'm going to try to get by itself. So to get x by itself, we're just going to subtract the 3y to both sides. It's going to cancel out, leaving me with x is equal to 10 minus 3y. And now that we have x by itself, we've completed the first step. We're going to take this expression that x is equal to and go ahead and substitute it in for x in the opposite equation. So we're taking it and plugging it right in there for x in our opposite equation. So that equation then becomes 3 parentheses. Here we're going to put in the 10 minus 3y in place of x equals negative 9y plus 30. So distributing the 3, we get 30 minus 9y is equal to negative 9y plus 30. Now that we have an equation that just involves our y variables, we try to solve by y by getting our variables to the same side. So in this case, we would be adding 9y to both sides. When we do that, we notice that these things are going to cancel each other out. So when these cancel each other out, we realize that the expression that we're left with is 30 is equal to 30. So remember, anytime that our variables cancel each other out, that's going to be one of our special cases, no solution or infinite solutions. If you're left with a true statement, like this statement, since 30 does equal 30, that will tell us that we're going to have an infinite number of solutions. So these are the same lines graphed on top of each other. So here we have an infinite number of solutions because our variables canceled out and we were left with a true statement. Looking at this next example, example 3, We're looking at which variable is easiest to get by itself out of these four. So the x, y, y, and x, we see we want to take the y since in the second equation since it's already by itself. So in this case, I'm going to take that expression, this negative 3/4 x plus 3, and I'm going to plug it in for y in my opposite equation. So when I do that, rewriting out that first equation, we have 3x plus 4. Here we're replacing the y variable with negative 3/4x plus 3, and the rest of the equation is equals 15. So now we have an equation with just x's. So we're going to distribute our 4. When we do that, we still have the 3x out front. 4 times negative 3/4 ends up being just negative 3x. 4 times positive 3 ends up being a positive 12. So here we have 3x minus 3x plus 12 equals 15. And here's combine our like terms. Remember, we have positive 3x, negative 3x, those cancel out. So we're just left with no variables, right? So here we're going to have just 12 is equal to 15. A common mistake I see is that a lot of people think that 3x minus 3x is just going to leave you with x, but that's not true, right? So if you just have the x variable, really the coefficient is 1. And if you took 3 minus 3, you wouldn't end up with 1. So really these things are going to cancel each other out, and you're just left with 12 equals 15. Now looking at that statement, we know that that is a false statement, right? 12 and 15, those things are not equal. So anytime you have a false statement after your variables cancel out, this is an example of no solution. So here these two lines are actually going to be parallel lines. They're never going to intersect or touch. Looking at one more example. Here we notice that out of these four variables, the one that we want to get by itself is going to be this y in the second equation, since it does not have any coefficients. So when I go to get that y by itself, here I want to take this equation, 3 equals 2x minus y, get the y by itself by subtracting 2x from both sides. So it's going to cancel out over here, and I'm left with negative y. Over here I have 3 minus 2x. And then really I want to get rid of this negative sign in front of my y, which really that's a negative 1. So I'm dividing everything by negative 1 here. So I end up with negative 3 plus 2x is equal to y. So now I've completed the first step. I've gotten y by itself. So I'm going to take that expression that y is equal to, in this case negative 3 plus 2x, and substitute in for y in my opposite equation. So when I write out that first equation now, and I substitute in that expression for y, I have 6x plus 8, then in parentheses I'm going to plug in that expression negative 3 plus 2x, and then the rest of the first equation is equals 42. So anytime you substitute, you should just be left with an equation that only has one variable, right? So either x or y. In this case, we just have our x variables now. So that's an equation that allows us to solve for x. So we're going to go ahead and distribute here. So we have the 6x, the 8 times negative 3 is actually going to end up being negative 24. And 8 times 2x is going to be 16x. So combine our like terms, 16x and 6x combine to make 22x. So 22x minus 24 equals 42. Adding the 24 to both sides, we get 22x is equal to 66. And dividing by 22 gets us our x value of 3. So once we've found our x value, in this case our x value of 3, we're going to take the value of x and then go ahead and substitute it in again for x to get our y value. So if I plug it back in to this equation where I already have y by itself, I already have y by itself, here this equation then becomes negative 3 plus 2 times 3. So I've just replaced the x in that equation with my value that I found x equal to, which was 3. Now, simplifying this, we get negative 3 plus 6 equals y. So negative 3 plus 6 combined to make positive 3. In this case, I find that my point is located at 3, 3. So the x value would be 3 and the y value would be 3. If you want to check it, you can plug in those x and y values back into each of these equations to make sure that they were correct.